Hello and welcome to today's ACEDS web seminar presented by ZyLAB. We're going to talk about 3 ways to know when computer-assisted and predictive coding techniques make sense for your case. We have 2 expert presenters today, but first I have a couple announcements for you. If you are new to ACEDS, this next slide is for you. We are a members-only association that provides training, resources, and networking to the e-discovery community. We also offer the Certified e-Discovery Specialist credential, which is held by hundreds of professionals across North America, Europe, and Asia. You can join today and start receiving a number of benefits exclusive to our members, including news content, on-demand web seminars like this one, our Bits and Bytes newsletter, and discounts on certification, and our 2013 conference. Next slide, please. The seminar today will be permanently hosted on our site and available on demand along with many others. They offer practical training and knowledge from top practitioners around the globe, and they're available to you right now if you are an ACEDS member. So for more information about membership or to sign up for certification, call Member Services at 786-517-2701 or go to aceds.org/join. Also, mark your calendars for this Friday at 1 p.m. Eastern Time. We will be hosting a web seminar on the new e-discovery amendments to the Florida Rules of Civil Procedure. You don't need to be a Florida lawyer to learn a lot from this presentation. We have 3 great speakers, including a circuit court judge who is the incoming chair of the Florida Rules of Civil Procedure Committee. They're going to give you a lot of practical advice for navigating e-discovery that extends well beyond Florida courts. So visit aceds.org today and sign up. All right, now I'm pleased to introduce our 2 speakers. Dr. Jan C. Schultes is Chairman and Chief Strategy Officer of ZyLAB. As the company's president and CEO from 1989 to 2009, he shaped ZyLAB into an information management powerhouse in countries around the globe. His leadership and vision led to ZyLAB's selection for high-profile engagements, including the United Nations War Crime Tribunals, the FBI Enron investigations, and the United Nations White House Executive Office of the President. Previously, Schultes was a lieutenant in the Intelligence Department of the Royal Dutch Navy. He holds a PhD in computational linguistics from the University of Amsterdam, and as of 2008, he holds the extraordinary chair in text mining from the Department of Knowledge Engineering at the University of Maastricht. Very impressive resume. Mary Mack is Enterprise Technology Counsel at ZyLAB. She is an attorney and strategic advisor for some of the largest product liability class actions, internal and government investigations, and antitrust and IP disputes. Mary's clients include the largest law firms, pharmaceutical companies, and insurance companies in the world. She is a member of the Illinois Bar, the ACCA, and the ABA section on litigation, and as well as holds certifications in computer forensics and computer telephony. Hope I'm saying that right. Mary is one of the leading speakers and authors on electronic discovery issues, technology, and the law. She is co-author of the popular book, The Process of Illumination, The Practical Guide to Electronic Discovery, as well as E-Discovery for Corporate Counsel, which was published by Thomson Reuters West. All right, reminder to our audience, if you have any questions for the speakers, type them in the chat box, which you will see on the right of your screen, and we will address them if time allows. Okay, Jan and Mary, thank you guys both very much for joining us. It's all yours.
Thanks, Robert. So today we're assuming we're speaking to a sophisticated technical audience, as well as an audience that's up on the controversy about predictive coding, keywords, and machine-assisted review. So today we're going to just touch on the what's going on currently with the controversy, and then we're going to do a deep dive into some of the methodology and compare and contrast some of the methods that you can use to reduce data set and to surface documents. With Jan here, it's the technical considerations are going to get a lot more play in this particular webcast, and then we're going to talk about what might be right for your particular case, some considerations that you might have when you're deciding what kind of machine-assisted review to use. So as a disclaimer, because of the new DC thing, where everybody has to say whether or not their advice is legal advice or not. Mine is not legal advice. This is educational information, nor is Jan's information legal advice. Purely educational, and if you need something for your particular case, and you're in the state of, or in the jurisdiction of DC, make sure you consult a DC bar attorney. So why all the fuss here? Part of this is an evolution, I think, of e-discovery. It wasn't so long ago where we were arguing about whether or not scanned paper was discoverable as ESI, or to take it a step further, whether or not you needed to produce emails. Was email a document? Was a spreadsheet a document? We were having those kind of arguments, and eventually we started to use keywords. And the volume of data was going up at the same time as the automated methods were allowing us to reduce the data sets, but still the costs were going up, and we had review rooms full of attorneys that were document by document, linear review, eyes on, looking at documents, paging through at very, very high hourly rates. So back probably 6-7 years ago, some of the going rates for linear review were in the $200 an hour range. Well, that rapidly flattened out, and so the per hour rate for linear review is a lot lower, but still, if linear review is used exclusively to review documents, there is a massive bill for corporate counsel or for other clients to absorb in a lawsuit. So we're seeing more of the impetus to bring machines to bear. And then we had the IBM Watson in the popular press talking about machine learning and predictive, and then we have the De Silva Moore case with predictive coding. Judge Peck putting out a paper called Search Forward, talking about how machines can do more of the review as long as it's overseen by legal personnel, and as long as there's transparency and quality control. So why all the fuss? I mean, part of it is the nature of, can a machine do what a lawyer does? And can you just basically set it and forget it? Or is there something more that's needed to oversee the process and make sure, and are there other methods that are equally as valid, if not more valid, for certain types of cases? So that's what we're going to be talking about today. We've got technology-assisted review as an overarching concept. What we're going to be talking about a lot later on with some very specific examples is the rules-based genre of technology-assisted review, and how granular you can get with your data to be able to reduce it, or to be able to surface documents in investigatory realms. And then we're also going to be talking about the artificial intelligence and machine learning, the predictive coding aspect of it, and how you might use the two together in a hybrid mode. Ralph Losey's got a new blog where he's talking also about, I think he calls it hybrid multimodal, but that it's not a one-size-fits-all technology. So the recent developments, De Silva Moore, all of you, I'm sure, have been following that, and I think if you piled all of the briefs and the opinions and the papers and the exhibits you probably have a pile to the ceiling. So the collaboration that was envisioned in the Cooperation Proclamation and then the new federal rules with the meet and confer, where it was envisioned that that parties would come to an agreement about simple keywords or modes of production, now it has moved into what I would call an early adopter stage for the machine learning or predictive technology. That in De Silva Moore, the question is, okay, both parties decided to use a particular technology, and they got almost to the altar, and then and then turned around. One of the plaintiffs turned around and ran away screaming from the altar, saying the protocol wasn't to their liking, and so that they didn't want to use it. And they not only did that, but they also asked for the recusal of the judge based on articles he had written and conferences he had gone to. And I was asked, what effect that was going to have on predictive coding, and I thought, well, it's either going to scare people away from it, or it's going to be like an immune response, and the judiciary is going to really embrace it, because this was such a frontal attack on the integrity of the judiciary. So instead, we're seeing in clean products, we're seeing more Daubert-like testimony experts coming in, and the situation there is the other party says, we want you to use the machine learning and the predictive technology because we think we're going to get better results. Your keywords aren't good enough. And so this is with Judge Nolan in the Seventh Circuit, and all eyes are on that particular case to see what comes out. There's very careful analysis and lots of expert testimony. So the thing that De Silva Moore and clean products have in common is the motion practice in the early part of discovery. The federal rules, I think, were designed to reduce motion practice and to get to cooperation, but because we're in an early adopter stage, we're seeing a lot of activity there. Now, the TREC study has been a study that has given us an idea of what to expect from machine-assisted reviewing. And Jan, do you want to say anything about the TREC study and its status?
Yes, no, absolutely. Can you hear me? Hello?
Yes.
Okay.
Yes.
I just want to make sure because I came from mute. Yeah, no, from what I've seen from the TREC studies just very recently, the final opinion of the TREC 2011 studies was the final results were released. It has taken a while, but like for many years, TREC has been like in the information retrieval community like the standard to evaluate information retrieval results. And this is a very important conference because information retrieval results can be very subjective to people's opinion. And what TREC has done over the years is to create best practices and guidelines on how to evaluate the results of text retrieval and information retrieval technology, such as document classification and search, and to do it in an honest way, to do it in an unbiased way. And as part of this TREC conference, a couple of years ago, they started with a legal TREC conference, which was very interesting. Initially, it started with the U.S. tobacco documents, which were highly polluted by OCR errors. And recently, the last 2 years, in 2010 and 2011, the Enron data set was used. And from what I hear is that they're now looking for a more suitable document set, and then there will probably be additional TREC conferences focused on automatic legal review. But there's been it's a very interesting ongoing process, which should also create best practice standards, and also create a model that we can all use to use machine learning, and also, most important, the evaluation of machine learning in the process of automatic legal review. Does that answer your question?
It does, Jan, thanks. And we touched on the DC ethics opinion, and one of the questions I'll just pose as an open question is that is unassisted machine learning without a set it and forget it, is that the practice of law in the jurisdiction of DC? So moving into rules-based coding, Jan, can you talk a little bit about why rules-based coding is a valid and superior method for some of the particular cases? We're seeing the judiciary say that keywords are not good enough. So what's the difference between keywords and rules-based coding?
Yeah, no, that's a very good question. Traditional keyword search just searches for keywords that are present in the text. And as we know for many years, also from the TREC conferences and from work done by Blair and Marin, keyword searches are limited. You do not always find all the relevant documents. You can also find a lot of documents that are not as relevant as the system presents them as. Now, what can be done with rule-based coding is that by using language analytics and text mining and content analytics and other tools from the exploratory search community to enrich the data. So what you're going to do is you're going to enrich the data with additional information which is not in the text itself. So it goes well beyond keyword search, which can only work with words that are, or keywords that are in the actual text. And after information has been enriched, what one can do is one can use rules which are highly focused on a particular case and that do not only use the text in the documents, but also the additional linguistic and semantic information which has been derived from the documents. And we'll show a couple of examples and how these can be used also in the rules, and then you can define very powerful rules that will help you to very easily identify documents quickly. Now, you've already brought up the next slide. How does it work? Now, if you look at the left side of this graph, typically what you see there is what we call artificial intelligence, machine learning, or predictive coding methods, which are very useful if you do not know exactly what you're looking for. So if you have a very complex case, a new domain, you don't understand the lingo, you don't know what's important and what's not important. And what you can see is that these machine learning, artificial intelligence techniques can give you interesting, new, and surprising insights. But at the same time, it requires that you use very well selected and also enough training documents per category. And the more categories you have, the number of training documents grows more than linearly with the number of categories. You also need to require extensive and unbiased evaluation for defensibility, exactly the same type of work that TREC has been doing and promoting. And after that, well, the model works or it doesn't work. If it doesn't work, you have to redo the training. It's impossible to patch the models. It's like it works or it doesn't work. There's very little in between. And it's also very hard to reuse models for other cases. And if you have more than one language, you can also run into trouble because the methods just don't work. On the other hand, there's the rule-based method. Now, with rule-based, what you do is you take the basics of keyword search, you take the basics of text mining, which allows you to add hundreds of thousands of different properties, which can be as well forensic, semantic properties, concepts, file, events, facts, relations between entities, anything you can find, varying from structural to syntactic to semantic information. And then you define rules which inference over all of the information that you have, which can be both textual information, but also all the additional information that you added to the documents. And for some cases, it's very easy to define these type of rules. And in addition, it's also pretty defensible because the rules are very explicit, where the artificial intelligence models are based on high-dimensional vector spaces with millions or trillions of numbers, and it's very hard to explain that to like a layman's audience, especially layman's in the mathematical layman's. And with rules, it's something people understand easier. Now, of course, you have to know what you're looking for. If you don't know what you're looking for, you cannot write rules, and writing rules also takes an effort, and you also have to evaluate rules. But in some cases, it may be easier and more defensible to use a rule-based approach than to use the artificial intelligence approach. Now, what is it that one's doing? When information is analyzed, there's a couple of different tools that you can use, and what you can see here is a graphic from a Swiss artist, which kind of shows what's happening. It's going from unstructured to structured. And what you can see here is that in information extraction, there's a lot of structural information like file and document properties. Some of them can, for instance, be SharePoint properties. And that's where a lot of low-hanging fruit is, because, for instance, if one of the SharePoint properties is that the project is confidential, you can use that in finding confidential or privileged documents. You can also recognize entities, relations, facts, and events, and we'll show a couple of more later examples. You can use machine translation. This is a big benefit. There's a lot of multilingual glossaries that allow you to translate semantical information from one language to the other. This allows you to also use this type of technology in a multilingual environment. You can also use natural language processing to resolve ambiguities and find more relations. This is very relevant in relation to the resolution of co-references and anaphora. I won't go into too much detail here, but you can read much more about this topic on our blog, because one of the potential risks of using artificial intelligence, and especially if you use a back-of-word approach, is that different documents with very different meaning can end up with as being exactly the same vectors in the machine learning, and they distort the machine learning quality.
Jan,
and this is where natural language processing.
You use the term bag of words. What does that mean to you?
Okay, yeah, sorry, I'm going a little bit too fast here probably. What we see is that a lot of machine learning is really a mathematical framework, statistical framework, and it's based on automatically learning patterns in mathematical structures, which are called vectors. These are like, rows of numbers and columns of numbers, and which are combined into what we call large matrices. And one of the problems is that if you have a textual document, the textual document doesn't contain any numbers. It doesn't contain any mathematical notions. It contains language. So one of the first things you have to do when you're using artificial intelligence machine learning is you have to translate your document from this textual representation, which is natural language or human language, into a mathematical format consisting of probabilities and vectors, one for each document, which you can then combine in large mathematical models. Now, when you do this translation, one of the generally used approach is what they call a bag of words. And a bag of words just looks at the frequency of documents. It takes into account how often a document occurs how often a word occurs in a document, how often that particular word also occurs in the entire collection, and then it uses a heuristic that low frequent words in the entire collection, if they occur highly frequent in a document, they are very distinguishing for the meaning of the document. Now, one of the problems with the bag of words is that it completely ignores the entire structure of language. It ignores synonyms, homonyms, it ignores negations, it completely ignores the word sequence. So it actually ignores all of grammar, and it also cannot handle synonyms. It cannot handle semantical variations. And One of the problems is if you use this approach is that it causes certain limitations in your machine learning model. And that's one of the things that you can prevent if you use different types of approaches.
Thank you.
Okay, let's go to the next slide. Yeah, so what you can see is that there's a pretty fundamental difference between predictive coding or machine learning on the left side here, where documents are coded based on decisions of the training attorneys that take certain training documents and then use, for instance, this back-of-word approach to make a mathematical model. And you know, a lot of the decisions that are taken in the process of translating a document into a mathematical model will influence the results of the machine learning. At the other hand, you have the rules-based approach where documents are coded based on the intrinsic content and the meaning of documents, where you actually make the rules handmade. It has some disadvantages because you have to make the rules, you have to know what you're doing. It takes some time, but the advantage is that in some cases it is more result-driven, it is more defensible, and it's easier to understand for people. If you go to the next slide, let's make this a little bit more understandable, a little bit more tangible by showing some examples. What you see here are patterns, semantic patterns, like for instance cities, companies, countries, currencies, that can be recognized automatically these days for many, many different languages and also multilingual environments from documents. There's hundreds or even thousands of entity types that can be recognized and that give an indication of what's in the document. These entities can also be normalized. You can also use pronoun and co-reference resolution to find more entities. But if you go one level beyond entities, you're going to look at, like, for instance, events or problems. It's also possible to recognize certain patterns like persons transporting an object, or quality problems, or somebody receiving a dollar amount, or person calling another person. And we've listed a couple of examples here, and with very, very high accuracy these days we can recognize these type of patterns, events, concepts, and relationships between entities. And this is all, you know, additional semantical information which can be used in a process where you can use rules to recognize certain type of documents, because the system is capable of recognizing whether the name Holland is used, for instance, as being a country, or in the context of a Mr. Holland, where it is a person. And this is something you cannot do with a back-of-word approach. So there's a much higher semantic fidelity in this system, and as a result, you will suffer from much less errors when you're doing these type of searches. Okay, if you go to the next one.
Yeah, I'll just say this entity extraction and the patterns is also one of the methods to use when you don't know what you're looking for, because it will surface things within.
Well, you know kind of what you're looking for. You know what type of patterns you're looking for. I think that's where artificial intelligence goes a step further. Artificial intelligence will also, you know, you don't have to teach anything, which can also result in the fact that you get like complete rubbish out of the system. But with rules-based, you kind of have to know a little bit what you're looking for. You have to know, like, okay, I'm looking for monetary transfers. I'm looking for quality problems. I'm looking for transportation issues. So you kind of have to know a little bit what type of information you're looking for, but you don't have to know the exact keywords. So this goes well beyond keyword search. There are certain results from machine learning and artificial intelligence that in some cases we're able to find, you know, even these type of concepts and relationships, although sometimes they are very tight relationships, and there's also, you know, sometimes some really strange relationships are being generated by these type of systems.
Yeah.
Okay, so what the process is first we do this entity extraction process. What we have as a result is highly enriched data, and then we can use all of this enriched data to define classification rules. And the enriched data is available as well very low level, like almost forensic information, for instance SharePoint project properties, but also very high level to identify documents with very strong sentiments or describing certain events like people meeting people at certain locations, being responsive for a particular case. If you go to the next slide, there's a couple of examples of such rules. And there's a big advantage of these rules, because where a machine learning model cannot be used between different cases unless like the cases are completely identical and you have exactly the same names, same custodians, same other types of properties. With rules, because they're more generic, and especially if you use like a meta rule framework where you have rules that can generate more detailed rules, you can reuse them between different cases, and that's a big advantage of this rule-based approach over the machine learning approach. And what you can see here is an example of a pattern which finds certain strong sentiments, and what you see there on the left side is like the objective of the pattern. In the middle you see you know, the syntax that's used to define these rules. It looks maybe a little intimidating, but it's really very, very easy to define these type of rules. And then at the right side you see the type of sentences that are being recognized. And so you kind of more or less need to know a little bit what type of rules or what type of sentiments or what type of problems you're looking for, and then the computer will automatically find all the documents which have these rules or these sentences in it, these patterns in it. And then instead of looking at all of the documents, you can only look at the documents with these type of patterns being present in them, or you can define rules that act on the content of these the results of these patterns. If you go to the next slide, there's another example. There you go. This is a typical rule to identify problems, and problems can be anything from like my roof collapsed here, or my car seat was poorly designed, and it's very possible to recognize these type of patterns with a computer by using what we call sentiment analysis, and emails or documents expressing sentiments are almost always the most interesting emails in a e-discovery case. And by looking for a specific type of problems or a specific type of major problems, it's possible to identify relevant documents very quickly. Another one on the next slide, please. That's where you can see one of the things, a rule that can be used to finding attorney-client privilege documents. And it's very easy to look in email addresses. For instance, you may be interested in all of the emails from a custodian's email address that's sent to and what you can see there is a wildcard star law firm domain. And one of the benefits of this rule-based approach is that it's very easy to write these very down-to-earth and very easy to defend and understand rules that the system immediately identifies all of the emails sent to the domain of the law firm or received from the domain of the law firm as potentially privileged emails. And this works very, very easily, and there's really no reason to select or classify these emails with a very complex artificial intelligence machine learning approach because there's simply just easier ways to get the job done. On the next slide, there you go. You can see another example of a privilege rule where different advanced search techniques are combined. Not only Boolean search, but also proximity and quorum, and the system uses not only textual information, but it also uses information which is retrieved from the structure of the email, maybe the forensic information, but also semantic information which has been derived with the text mining. So it's a very powerful, explicit, transparent method, to catch the low-hanging fruit in technology-assisted review. Having said that, the combination of the two is very interesting. But in some cases, it is very clear what you're looking for, and then machine learning may be an overkill, because one should not underestimate the effort it takes to train a machine learning system, to evaluate it in a way that's defensible and acceptable by all parties. And there's a big risk that in that path, in that process, you find out that you're dealing with data which is highly multilingual, or data where people use a lot of different words for the same things, or some of the other restrictions we've explained in more detail on our blogs and websites, and also in the white paper that we'll refer to later in this webinar. You find out that it's not possible. Machine learning will never reach the quality that you're looking for, and then all the efforts you implemented in training and selecting documents for machine learning is a waste of time. And that's something you do not, there's no guarantee to success with machine learning. And that's one of the risks that you have to take into account, and therefore in some cases it may be more common sense to take an effort that is not as fancy and takes some manual efforts, but that will lead to more guaranteed results.
Yeah.
Okay.
Okay. Both methods want to reduce the amount of data that needs to be reviewed by it. I remember an attorney that was telling me about his automated way to search for keywords, and it was that he had all of the documents all over a conference table, and he had a different Post-it color for each keyword. So we've come a long way since that methodology, and then simple keywords, certainly into proximity and then quorum searches and other types of searches, number ranges, to be able to reduce data. But Jan, part of this is there's a data reduction exercise, and then there's the surfacing the facts of the case exercise. And which methodology do you think is best for data reduction versus surfacing the facts?
Well, data reduction rules-based is really the direct, guaranteed to success approach, and surfacing facts, especially facts where you have absolutely no clue that they're down there somewhere. That's where artificial intelligence and machine learning could do a good job. But if you know a little bit what you're looking for, rules-based approaches might also help you there.
So if we were to contrast the two methodologies, in terms of predictive coding, you talk about defensibility. Is it that you can't explain why the document is in or out that makes it less defensible?
Well, unless you have a PhD in mathematics and statistics, you can think in 100,000 dimensional vector spaces. It will be very hard for people to understand why certain documents are not included and others are.
Okay, and what we have here to compare and contrast is that we need a high degree of cooperation. Do you think that there'll come a time when predictive coding will just be accepted, no matter what kind of predictive coding it is?
I think predictive coding is especially has great economic value for expert witnesses. They're like DNA technology and other hard to understand technology. It will always be challenged by opposing parties. So when one uses predictive coding, one wants to make sure that there is absolutely agreement and a high degree of cooperation. But there's always the risk, like in the De Silva case, that somebody walks away from the altar and you've done all your efforts for nothing. But having said that, I'm a great believer and fan in artificial intelligence and machine learning myself. And technology can be very, very powerful. It has shown its power in intelligence and law enforcement applications. But for legal review, it just has to be a little bit more defensible. A big difference between e-discovery and, for instance, law enforcement is that in law enforcement, once enough evidence has been found against a suspect, that's enough. There's no need to find every little detailed piece of evidence. Where in e-discovery, the entire set needs to be reviewed. Everything needs to be sorted, and you want to make sure that everything's done properly. And it's more like a sorting problem than a searching problem. So predictive coding and artificial intelligence and machine learning can, like what you said, can really help to surface facts, surface certain documents or certain things you are not aware of, certain relationships. But there's a big risk it will surface relationships that are accidental or false positives, and it will be very hard to prove that the system did everything 100% or 90% or even 80% correct. And especially when you have large collections with a lot of different categories, the problem will be even harder. Now, on the other hand, what you have.
Can you say a little bit more about having multiple categories and what the situation is with multiple categories in machine learning?
Yeah, no, that's another good question, because machine learning is like automatic classification, and then there's two types of classifiers. There's binary classifiers, which can separate two different classes from each other, and there's also different approaches to classify more than two classes from each other. Now, you can compare this with a computer recognizing black and white, which is much easier for a computer than to recognize 1,000 different scales of gray values. And that's the whole problem of machine learning. The more categories you have, the harder it will be for the computer to find reliable boundaries based on certain feature extraction and selection technology, to separate different documents from each other in a correct way. And that's a problem. The more categories you have, so if you have like a lot of different reasons for documents being privileged or responsive, and you want to automatically classify the documents in all these different categories, you take a big risk that certain documents are not properly categorized, and also you need many training documents per category, and this is a non-linear relationship. So if you have like 2 times more categories, you need at least 4 or maybe even more times documents to train the different sets. And then sometimes it may appear at the end of the process that because of the way how you extract features and how you represent documents in vectors, the computer is not able to classify all of the machine learning systems. None of them is perfect. There's always a certain amount of error. And it is hard to predict where the error will be. You have to do it from a case-to-case basis.
Interesting. So, say a little bit more about the technical considerations. So many of us work on cases where you might get, let's say, 10 initial custodians, and then you get another 5 or another 10. What happens in the predictive model, and what happens in the rules-based model in that regard?
Yeah. No, with the predictive coding methods, after you've selected training documents, per category, which is a very careful process, because garbage in, garbage out. You have to use the right documents, and if for whatever reason there's more documents at a certain moment in time that you weren't aware of in the beginning of the process, or if there appear to be more categories, you have to start all over again. Machine learning models are based on making a representation of all the documents that are around there, and if suddenly in your collection there are documents which you did not took into account into your initial training set, you have to start all over again. The computer cannot learn what it didn't know from the beginning. So row collections is a problem.
When you say start all over again, do you mean like rebuild the index or the vectors, or?
Yeah. Well, you have to,
rebuild
what you have to do is you have to rebuild the machine learning process. You have to do everything from scratch, and that's a lot of work. So if you have like 100,000 you have documents, and then you get another 10,000, and in those 10,000 there's new categories or there's other information that you didn't anticipate. You have to start all over again. So that's,
okay. So in that regard, if you had a live review, it would be important to have categories separated by already reviewed, not reviewed, by category, because you might end up adding to a category that you thought was complete.
So in addition to that, if you happen to have like different language documents in that collection, you're also going to be in trouble, because these type of models cannot handle either documents with multiple languages within the document or different collections of documents with multiple languages. It cannot. Machine learning doesn't make any sense, especially not with the back of words approach. If there's like important numeric values or digits, or if you have technical drawings, or you have documents of many different files and types and different type of language. The language that's used in email is completely different language that's used in like formal memos. And all of these things, have to be taken into consideration when you're using automatic document categorization technologies such as predictive coding or other machine learning from the artificial intelligence.
So Jan, can you see if you used more of a hybrid approach where you identified foreign languages and translated them, or
No, there's a lot of what we see.
In the right way that you would be able to include, in addition to the raw document, you might be able to include some enriched.
No, absolutely. Like the principles and the basic ideas behind the machine learning and the artificial intelligence are all very valid. But one has to take into consideration that language is not just a bag of words where you can completely ignore syntax and semantics. And by taking that into consideration, there's a lot of proof in scientific research which is done in the field of information retrieval and text mining, that by taking the actual meaning and structure of language into account, systems can become highly accurate, much more accurate and more reliable. But there will always be collections and there will always be problems where machine learning will not be able to do the job right. And also a generally accepted notion in machine learning is that if you really understand the problem, if you really know what's going on, if you really understand what things are relevant, which expressions, or what distinguishes a document from the other document, then it's always easier and it's always a more high quality result if you write code directly for that problem. And writing code directly for the problem also implies writing a rule to immediately identify such a document and then take action based on the result of your rule. But a lot of these artificial intelligence machine learning approaches to statistical, but also like other variations like neural networks or genetic algorithm approach, and there's a whole lot of different approaches. They're suboptimal problem solvers, so they can do a very good job if you have no clue what's going on and you don't know what the parameters of the problem are. But if you do understand what the parameters of the problem are, you can always write a more accurate solution. It will take some time and some effort, but that could very well be less effort than training a machine learning algorithm.
Good. And we put out a few legal considerations, and it's more around the environment that the particular case finds itself in. Certainly, the jurisdiction and the judge or special master, and then also whether or not you're willing to risk early motion practice if you don't have the extraordinary cooperation that's needed right at this time, because it is early adopter time. So the top 3 ways that we see to take a look at whether or not to use automated methods at all would be, certainly the size of the case and your whether or not the data is consistent enough to allow coding, and then depending on your own experience level with e-discovery and your attorneys, the associates, the partners, everybody working on the case, as well as the counsel that you're working with on the outside, or on the inside, I should say, and then how cooperative your opponent is, and then the last one would be the confidential nature of the data, because these early adopter ones, particularly Silva, is required the disclosure of the seed set of the non-responsive, which can be problematic for organizations that face serial litigation or have trade secrets that they want to protect. As we move through this, we'll find ways to deal with these types of issues, but that's where we are right now. So, Robert, do you have some questions queued up that you'd like to present?
Yeah, we do have a few questions from attendees. First, do you guys want to say a couple words about your white paper?
Oh, certainly. Well, as we're having, as we're going through questions, those of you who'd like a PDF of some of the slides that we've shown today with the rules-based coding and examples of that, and a little bit more of an explanation of how to use them, are welcome to send me an email, and I'll make sure you get the white paper. You can also download it from our website, but we wanted to give you an easier way to access this. Katie Wood from the Enterprise Strategy Group put together a really nice white paper that will help explain it to others, because you'll probably understand it yourself, and if you need to move it within your organization or across organizations, this would be a nice tool for you.
All right, great, Mary, thank you. One attendee wants to know, for the fine privilege rule, does it work only on the top level emails, or does it drill down to earlier emails in a chain?
It would drill down to earlier emails in the chain as well. You're looking for the metadata in the to and from fields in email. It's a fielded search, and so it would drill down, or it should drill down. Jan?
Yeah. No, absolutely, and that's also one of the disadvantages of machine learning. If you have emails where the previous emails are also repeated, and those documents are not properly separated into individual messages, that they may also confuse the machine learning, and that's something where you don't suffer from with these rules-based approach, because you find the emails, you can immediately tag them all, or you can take the whole trail and prevent any confidential privileged email to show up in the production.
All right, fantastic. Another attendee wants to know if you guys can identify the types of documents that each type of method, rules-based and predictive methods, struggle to either identify or process. Can you guys say a couple words about that? Mary, you first.
Sure. Anecdotally, what I have heard is that spreadsheets are problematic in the machine learning, where if the if the processing engine is strong enough to to handle spreadsheets and to be able to make it indexable, and is able to handle numeric ranges, then the rules-based approach would be better for that financial data. That's the corpus of data that I've heard is most problematic, and because of all of the activity around LIBOR mortgage-backed securities, you do have textual data, but you have quite a lot of numeric data percentages and things of that nature. And so that's one document type. Jan, you were mentioning other document types that...
yeah, well, technical drawings is another good example for the same reason, because it contains a lot of numbers. And also, any document with multiple languages. And in general, if you have a lot of documents that are all very different in lingo, so in language used, an email is written in a different way than a memo, and you also have documents that are very different in structure, or if you have a lot of compound documents that are not processed well, it doesn't work.
All right, Mary, do you think
there's more detail about that also in the white paper that we refer to. And if people have certain questions like, okay, this is the type of documents I have, what would you advise? Please feel free to send us an email, and we can, because I think this is a very open question, and it really depends on the type of documents and the type of categorization. Also, if you just want to recognize two categories from each other, it's pretty straightforward. But if you want to recognize 20 different reasons for being responsive, it may be much harder.
Yeah, I'm sorry to cut you off there. Mary, sorry to cut you off as well. Go ahead.
Yeah, one of the things we see is that certainly in linear reviews or even with attorneys doing bulk categorization or rules-based reviewing, that there are a number of categories. So, for example, if you've got a second request or something, you've got multiple specification numbers that you need to categorize for, and rolling collections. So it can be, but then again, your second request has a lower evidence set standard, so the quality needs to be a little bit lower than, say, in a white-collar criminal case. So it's not only the type of document, but it's the type of case that you're using, and what is the evidence standard and the production standard that you're facing.
Mary, another question. Do you think the disclosure of the seed set will always be required in the future? And also, can you add to that what effect that disclosure is having on attorneys' willingness to use predictive coding?
I don't think it's going to necessarily be required all the time in the future. It was required in this case, the De Silva Moore case, and I think certainly in the beginning it will probably be more common to disclose the seed sets because of transparency, and how do you know the machine is coding in the right way? How do you know the inputs to the machine are just as important as the machine learning itself. Much like the rules-based coding, the rules are just as important as the results of the rules. But with rules, you can say, here's what the rule was, and it's either in or out, and you don't necessarily have to disclose seed set training sets. That's a new thing, and it really put a chill, I think, in many inside counsel that are concerned about follow-on litigation. So they get sued by somebody, and in their seed set, their non-responsive seed set, they have mentions of other products or other problems or other or something else that even with protective orders, there's a sense that productions sometimes are shared, and so there, whether rightly or wrongly, there is a chilling effect there. And I've also heard that outside counsel is concerned because the seed sets have been described as the quintessence of the work product. I mean, these are my legal judgments of what's in and out. Now, the countervailing to that is, well, you have to produce it anyway. If it's responsive. And then
we've
got Rule 502 for privilege. So that should give some cover to privileged documents being inadvertently produced in seed sets. But when you go to conferences and and the audience is asked how many are using a 502, if you get half of the hands in a sophisticated audience, that's a lot. So I think that the seed set is going to be with us for a while, but probably with better quality control and acceptance of quality control methodology, we'll probably find a better way to do that.
Yeah, I think
you want to add to that?
Yeah, well, I think it will be more interesting for both parties, or actually for the receiving party, to see the results of the test set, because when machine learning, there's always a training set, a seed set, which is typically like 9 times larger than the test set. But the test set shows how well certain documents have been classified and which documents are properly classified and which ones are not properly classified. So you can see what the actual precision and recall is. And by looking at the training set, the seed set, well, you actually don't know that much. But by looking at the results of the test set, you know exactly which type of documents are properly classified and which ones are not, and that gives you a better understanding of the quality of the system. So I don't know whether those test documents were also included in the seed set that was requested to disclose. But for me, if I have to evaluate the quality of machine learning system, I would always be mostly interested in the results of the testing and on the actual test documents, and then especially the test documents that went wrong. So the false positives and the false negatives.
Jan, in using the rules-based approach, who's the person that's actually setting up or defining those rules?
Well, yeah, that's a very good question. Well, this is something that lawyers can do very well. Lawyers are very good in defining rules. It's a paralegal that can do it. It can be done by IT folks. It can be done by records managers, by content specialists. So it's you don't need to be a machine learning specialist.
Now you're talking about the syntax there, Jan, because the attorneys with the knowledge of the case would know what they're looking for.
Yeah.
And so so actually putting the syntax together, much like complex Booleans are sometimes dictated by the attorney, but it's an analyst that actually puts the Boolean string together and then tests that out.
Yeah, absolutely. Yep.
All right. Well, good advice from both of you guys. Unfortunately, we are out of time. Mary and Jan, thank you both for being here and for the great presentation.
Oh, thank you.
Yeah, thank you.
Yep, thank you very much.
Thank you guys very much, and thank you to our attendees as well. When you guys log out, please take a few seconds to fill out the webinar survey, and we're going to shoot you an email probably in a few hours when we post the webinar recording. All right, see you all next time. Bye.
All right, thanks for your kind attention.
Bye-bye.